Welcome. I'm Richanne Watson, and I'm with Data Rich Consulting. I have been programming in SAS for over 20 years, and I'm currently working on a book dealing with clinical graphics. Today, I'm going to talk to you about controlling the appearance of your graph with colors. So as long as I can remember, I've always loved to color, and even as an adult, I have lots of coloring books, and I have map colors and crayons and colored pencils. So I thought, can I take this to SAS, my love for coloring? So I'm going to talk today about how to do colors within your SAS outputs. There are different approaches. These are the four that I typically use. I'm going to be concentrating today on discrete attribute map and style template. The other two options are discussed in the paper. So SAS has over 50 styles available that you can use. And you can see that they vary vastly based on color, based on font, based on size. There are a number of attributes that vary, and depending on what your needs are, you can pick from one of these 50 styles. But sometimes those styles don't always meet our needs. So we're going to talk about how to adjust these colors using various techniques. The first one is using an attribute map. The colors are based on a rotation, so if they're missing data or data is not sorted correctly, your colors can end up being incorrect based on how you want to visualize it, or they may not be consistent from each run. How do we control that so that the colors are always consistent? You can control that by using an attribute map. So for this presentation, I'm going to focus on building an attribute map using a SAS data set and referencing that attribute map on the proc.sg render. The paper also talks about how you can build your attribute map within the proc template and also referencing it within proc template. But for the presentation, we'll focus on the data set and proc.sg render. When you create a data set to house the attribute map, you only need to include the necessary attributes. You can include all of the attributes that you want, but you only need the ones that are required for that particular output that you're trying to produce and for the attributes that you're trying to control. Here are some of the types of fields that are needed in your data set. You have to have the ID variable, but you have other attributes such as fill color, line color, marker color. You can include things like symbol, size, and line pattern. And when you create your data set, you can have multiple data attribute maps within the same data set. So in this example, I have two attribute maps. One is called treat color, which is my colors based on various colors of pink or various shades of pink. And then I have treat color 2, which is the various shades of turquoise. And so now I have two different attribute maps. I'm using the ID variable to uniquely identify those attribute maps. Now that we've created this attribute map, how do we get it into our actual template so that we can reference it with our plots? So now that you have it, you're going to use your discrete attribute within proc template to now associate the attribute with the corresponding variable. So within the discrete attribute, there are three options that need to be used in order to make that association. Your first one is you have the attribute, and this is actually the name that you're providing for that association. This attribute is going to be used in other portions of your proc template so that you can actually reference this map. The next is your variable, and you have to now associate the variable that's going to be used within the attribute map, and you're going to use the var statement for that. In our particular example, our variable that is going to be using the attribute map is our TRTAN variable, our treatment variable. And then the attribute map specifies the name of the attribute map that is used. So if you recall, in the previous slide, we had two attribute maps specified in the data set. We had treat color and treat color 2. For this particular template that we're creating, we're going to use the treat color. Now that we've specified our discrete attribute statement, we can now use that associated name, the attribute, and reference that on our plot statement. And so you'll notice in the bar chart statement for the grouping, we are using color var as our group variable versus just using TRTAN. If we would not have the attribute map, we would typically use our treatment variable as our grouping, but because our treatment variable now has this attribute tied to it, we want to use that attribute map associated name, which is the color var association. And now this is going to tie those colors with that variable, that treatment group variable, so that we get the colors we want on our output when we go and render it. So now we've created the template. We've made our template so that we are referencing a discrete attrvar, but now we've got to make sure we actually use that attribute map when we render that template. So when we go to call proc SG render, we're going to specify on the datom option which attribute map we are going to actually reference. And so we're saying we want the attribute map that is stored in the atom lib name that has a data set called attrmap. So it's now going to point to that particular data set and grab the attribute map that's stored in there. Okay, but what happens if later on you decide you want to change the color? So now my favorite color is no longer pink, it's turquoise, and I want to change all of my output to now be turquoise. And so now instead of going in, I can go in and I can go change my discrete attrvar statement. So where my attrmap used to be treat color, I can change it to treat color 2. And now all of my outputs would have that new attribute map associated with it. And you can do this if you know that it's going to be a one-time change. But what happens if you know that you have to switch back and forth between two different types of attribute maps, or you know that you're going to have to be referencing multiple templates to use the same attribute map? So we have multiple templates that want to change to treat color 2. I know in my industry, we have to do double programming for everything. So that means if I change the template, it has to be fully revalidated. I don't want to have to go in and touch that template over and over just to change my attribute map. So there's an easier way to do this. You can actually do this on the rendering statement. So when you go to render that template, you would just now specify datvar and specify the variable and what attribute map you want to associate it with. So you'll see I have two statements here. We have the first one referencing the treat color. The second one is referencing treat color 2. So now I can go back and forth between the two colors without ever having to change that proc template. So when I was using my pink colors, I had my datvar equal to treat color. I get my nice pretty pink colors, and then now somebody says I would rather have it in turquoise, and now we'll just change that one statement on the proc SG render to datvar equal to treat color 2. And so now I have my turquoise. There are other approaches. The next one we're going to be talking about is a style template. Typically, when you're dealing with the style template, you're going to start with an existing one rather than try to create one from scratch. This is because the style template is so complex. There are many styles that SAS offers. As I mentioned earlier, there are over 50, and you can determine which one you like the best, the one that's closest to what you need, and start with that as your starting point, and then modify only the elements that you need to modify. There are different ways to modify these elements. You can use a modification macro that is built in within SAS. You can use the style statement or the class statement. I am only focusing right now on the style statement and the class statement. There is an explanation on how to use a modification macro within the paper. But before we get into that, just want to go and give you a little sidebar of why using these different approaches is beneficial. If you were to say you're out of curiosity, want to go in and see what's sitting behind the styles daisy template, you can run proc template source styles.daisy, and it will actually write all of the code that is sitting behind that style to the log. When I ran the code, I saw 850 lines written to the log, and my first reaction was, yikes. That's a lot of code that I have to shift through just to try and figure out what I want to change. But one of the things I noticed was that it inherited from HTML which was another style. So then I had to run the same proc template source code to see what code was sitting behind HTML. When I did that, I noticed that HTML inherited it from default. So then I had to run the same code again for proc template for default. And when I did it for default, there was over 1,000 lines of code. Now, granted, some of the lines of code would be overwritten for each style depending on what you're inheriting. But in short, you're basically having to change almost create 1,000 lines of code just for one style. Just for graph colors alone, there was over 150 lines of code. I personally do not want to go and try to modify that. I want an easier way. So there has to be an easier way. So I'm going to talk about some easier ways to actually change the style without having to go through thousands of lines of code. When you're creating a customized style, you want to give it a name. You have to give it some type of name. In this particular example, I'm calling it My Style 2. And by default, the style is going to be saved to the sasuser.template area. You can actually save your templates to a permanent location, especially if you're going to have others within your company use the same styling. But for right now, I'm just using the default, which is the sasuser template area. For our data, we had 3 groups, and we want each group to be a different color. We are going to use the style statement specified in this example, just style, graph, data, and with our color equal. When we use the style as illustrated here, it's basically telling us that we only want to change the color. All the other attributes associated with that will have a non-group data attribute. This means that all the other areas will have the same color, same marker, same line pattern. We're only changing the main color for that graph data 1, graph data 2, and graph data 3. Now, right now, that doesn't make a lot of sense. It will become clearer as we start explaining some of the other styles that use different features or different options, and then when we actually show the illustration of the graphs, it will actually finally click. At least for me, that's what happened. It was like, eureka, I figured it out. So this statement here looks almost the same as the one we previously did. The difference is now you see that we're using style graph data from graph data 1. So basically that's saying inherit all of the options or all of the features from graph data 1 for graph data 1 from itself, but I only want to change the color. So everything else is going to be inherited from the parent styles Daisy, but only changing the color. So again, this probably isn't very clear when you're just hearing it in terms of words. As you say, a picture's worth 1,000 words, and we'll actually show you a picture in a minute. But let's talk about the class statement. So now people start seeing the use of the word class. Class statement looks exactly the same as the previous one, which is just a plain style, but we just replaced a word. So what's the difference between style, style with a from clause, and class? Well, style with a from clause and class are basically the same. Class has an implicit from self. So basically class is saying class graph data from graph data, and I realized that graph data was typed in twice for the class statement. It should have only been typed in once. But essentially it has an implicit self, and so it's saying inherit everything from the parent for graph data 1, just change the colors. So if you want to inherit everything for the grouping aspect, you can either use style with a from or a class. If you only want to change the color or change the one element and use a non-grouping, then you would just use style. Again, this probably is not very clear until you actually see a picture. So this is style without the from. So this is just style graph data / color equal. And you'll notice that we have our pale pink, our pale turquoise, and our plum, but the lines around our bar charts are all blue. That's because we only said to change the color. Everything else, all the other attributes, are going to be using non-grouped data. So that's basically saying take the first color in our styles.daisy and use that for all of our unique values. And so the first color in that rotation is blue. So that's why it is considered non-group data, because it's just going to make everything look the same in regards to the contrast, the lines, and the symbols. But if we use a style with the from or the class statement, we now see that the line around the bar charts are now different colors, because now it's taking and inheriting the actual attributes from graph data 1, graph data 2, and graph data 3 from the Daisy style. It's only changing that fill area color. Taking this a bit further, there's some graph options that use a color response or a color model, and you may want to use that so that you don't have to actually specify a list. You can also use on the color response a color gradient, and you can actually change the color gradient that is the default for the particular style. When you are going to change the color gradient, it's a 2-color ramp or a 3-color ramp. There are 4 predefined color ramps: the 2-color ramp, the 2-color alt ramp, 3-color ramp, or the 3-color alt ramp. If you're using the 2 colors, then you have a start color and an end color. And you'll see in this example I have deep pink and dark turquoise. If you're using a 3-color ramp, you have to include the option of neutral color, which is your middle color. So your start color is your lowest color, and your end color is your largest color. And so basically SAS is going to determine a grading from the start to the end, and if you have a neutral, that neutral is going to be your middle color. The color ramps with alt in the name are used for markers, plot lines, while the colors without the alt are used for the fill areas. In order to use the color ramp that you just defined, you need to actually specify that on your ODS style statement. And so you'll see that we have this color ramp that we defined in our style called myGradient. I now have to reference the myGradient on the ODS PDF style equal. And this is now going to associate that style with that particular output that I'm going to be producing. I can then now reference the color model, which was the color ramp alt ramp, which is basically saying I want to now do my fill areas. My lines, my markers, my markers. So by default, this is going to be our Daisy. It's based off of gray as a starting color and dark blue as the end color. And you'll see that SAS automatically created a grading, and you'll show that from going from gray to dark blue, you have a blending of the 2 colors. What happens if we have 2 vastly different colors, say the deep pink and the dark turquoise? SAS will still do a blending of the 2 colors. And me personally, I like this coloring better. I love bright colors, and pink happens to be my favorite color, followed by turquoise. And so this grading to me is much nicer than the graded blue. So in conclusion, you're not limited to using standard colors in a predefined style, and there are different ways in which you can actually modify the colors. You have the options on the begin graph statement and the individual plot statements, which are defined and outlined in the paper, the discrete attribute map, and you can use proc template. So happy coloring, and I hope you enjoyed this presentation. Thank you.